Hey everyone, welcome back to another Vibe video for AP Stats. I'm Ria.
I'm Romy,
And I'm Mahadev.
and today we're going to be talking about extraneous variables, confounding, and lurking.
Let's start with the basics. An extraneous variable is any variable that isn't the main focus of the study, but can still influence the outcome. That's a problem because it makes it harder to tell whether the relationship we see between the explanatory and response variable is real or not. In AP Stats terms, these variables threaten the validity of our conclusions. They can make us draw the wrong conclusions about cause and effect. Now, if we recognize an extraneous variable and take steps to control it, meaning we hold it constant, then it becomes the control variable instead. Finally, we divide extraneous variables into two types, confounding variables and lurking variables. And that's what we'll break down next.
So let's talk about what a confounding variable is. A confounding variable is one that is not the explanatory variable, but it still has the potential to affect the response. The key point is that it presents in the study. It might even be measured as well. The problem is when a confounder is involved, we can't tell if the changes we're seeing in the response variable are due to the explanatory variable or due to the confounding variable. So it confuses the results, hence why it's given the name confounding variable. Also, confounding variables are typically related to the explanatory variable, which makes the mix-up even trickier. We'll look at an example next so you can spot them more easily.
Now, what is a lurking variable? A lurking variable isn't part of the study, but it can quietly influence both the explanatory and response variables, make it seem like they're directly connected when they're not. This kind of variable doesn't just distract us, it misleads us. It can create a completely false impression of causation when in reality there's another factor driving both these variables behind the scenes. One of the biggest challenges with lurking variables is that we often don't know they're there. And because observational studies don't assign treatments or control conditions, lurking variables are always at risk, which is why we avoid making casual claims from observational data. In short, if a variable affects both the explanatory and response variable but is not included in the study, it's lurking.
Now let's take a look at an example. A researcher notices that cities with more fire stations also report more fire damage per year. And what is the most probable explanation? Take a moment to pause and try to answer this question yourself. Um, But the most likely explanation is that a lurking variable is responsible for the observed association. In this case, the lurking variable is the size or population of the city. Larger cities naturally have more buildings, more people, and therefore a higher risk of fires. Because of that risk, they also tend to build more fire stations to keep up. So it's not that fire stations are causing more damage, it's that bigger cities lead to both more fire stations and more fire incidents. That's what makes city size a lurking variable. It's not part of the study, but it's affecting both the explanatory and response variables behind the scene.
So because confounding variables and lurking variables can be kind of confusing and easy to mix up, we've created a table for you guys so that you guys can tell the difference. So confounding variables are mostly for experiments, while lurking variables are mostly for observational studies. Confounding variables, it makes it unclear if the result is due to the explanatory variable as it also affects the response variable, while for lurking variables, it falsely creates a link between the explanatory and the response variable by affecting both. Lastly, for confounding variables, researchers will try to account for it before the experiment begins, usually through randomization, while lurking variables are not accounted for before the study as the study lacks that randomization.
So this is an AP question. Take a minute to pause and read the question. Yeah. So the correct answer is A. Um, this is an experimental study because participants were randomly assigned to either exercise or read, distinguishing it from an experimental or observational study. Choice B is incorrect because random assignment helps control for confounding variables, making it unlikely that a confounder, rather than the explanatory variable, caused the change in blood pressure. Choice C is too absolute. Lurking variables can still affect results even in randomized experiments, though their impact is reduced. And choice D incorrectly reverses the variables. The explanatory variable is the activity, which is the exercise or reading, and the response variable is the change in blood pressure.
Finally, let's take a look at another AP question. Take a moment to pause and read the question. So the correct answer is smoking, which is a potential confounding variable because smoking will cause more severity in lung cancer, which is a variable that affects the response variable and doesn't have a relation to the explanatory variable.
Thank you guys so much for watching. We hope this video helped you on understanding confounding and lurking variables. If you guys have any more questions, feel free to visit vikinginitiative.com or text in the WhatsApp group chat, and one of us will respond shortly.